Hello everyone, in today's video we are going to cover zero and negative exponents. Our learning targets for today are I can evaluate numerical expressions involving zero and negative exponents, and I can simplify algebraic expressions involving zero and negative exponents. First, looking at negative exponents, when an exponent is a negative number, we think of it as taking the reciprocal. What that means is if we have x to the negative n power, then it's 1 over x to the n because it's in the numerator. The reciprocal of being in the numerator would then be in the denominator. Or we could also have 1 over x to the negative n. This is in the denominator, so it would go to the numerator, which would be x to the n. We don't want to have negative exponents in our answers, so we want to think of if we have a negative exponent, it's going to go to the opposite part of the fraction that it is already in. If it's in the numerator, it's going to go to the denominator. If it's in the denominator, it's going to go into the numerator. And then once we switch it, it becomes positive. Another way that we can visualize it, again, if we have a base to a negative exponent, so say 4 to the negative 2, this is going to become into the denominator of 1 over 4 squared. It's in the numerator, it goes to the denominator, and vice versa. If it were in the denominator, it would go to the numerator. We don't want to leave negative exponents in our solutions, so we use this rule to help us write all solutions with a positive exponent. Now looking at zero exponents, any number raised to the power of 0 is always 1. So if I have 12 to the 0, that's 1. 100 to the 0, that's 1. We'll see why here in this example. Now, looking at this example, we'll see why anything to the 0 power is 1, and then any negative exponent is a fraction. So I can see that I have a power, more specifically 5 to the power of something, and then these have values. So 5 to the 6th, 5 to the 5th, etc. All these values are here. Now, as I'm moving to the right of my table, I can see my exponents are decreasing. Each time I decrease by an exponent of 1, my value is dividing by 5. So I can see that these values are getting smaller each time by dividing by this 5. Now, when I get to 5 to the first and I divide by 5, 5 divided by 5 is a value of 1. And then when I go to 5 to the negative first, 1 divided by 5 would be 1/5. And 5 to the negative 2, 1 divided by 5 would be 5 times 5, which is 1 over 25. So I can see that 5 to the 0 has to follow my pattern here of continuously decreasing by this value of 5. When I get to 5 to the first, I divide by 5. 5 divided by 5 would give me a value of 1. And then as I go into my negative exponents, these become fractions, exponentially getting smaller towards 0. So if any base raised to the power of 0 wasn't 1, it wouldn't follow this pattern, and I couldn't have exponents in the first place. That's why anything to the 0 power is 1. Now, we also have to be careful when we raise a negative number to a power, because if we just rely on our calculator will sometimes lie to us. So in these examples, we have negative 2 parentheses raised to a power. Now, when I have something raised to a power, it tells me how many times to multiply the base by itself. So negative 2 to the 6th would be negative 2 times negative 2 times negative 2 6 times. Now I can see that I have 6 negatives here. So if I have 6 negatives, this is going to give me a positive value of 64 because 2 to the 6th is 64, but negative 2 to the 6th would also be 64. Now, if I were to put this into my calculator without a parenthesis, my calculator would be 2 to the 6th because it follows order of operations, and then it would leave the negative sign for the end. So it would give me negative 64, which I don't want. Now, when I have negative 2 to the 5th power, this is only 5 negative 2's. And if I have 5 negative 2's, that's a negative times a negative times a negative times a negative times a negative, which would be a positive times a positive times a negative, which would give me an actual negative value. And this is negative 32. So to generalize this, we can say that when we raise a negative number to a even exponent, the number will be positive, and if the exponent is odd, then the number will be negative. Because when I have two negatives, it makes a positive, and if I have just one negative, it makes a negative. Now looking at our sample problems, we're going to simplify each expression and evaluate where appropriate. So number one, we have 2 to the negative 2. Remember, when I have negative exponents, I want to take the reciprocal. So right now it's in the numerator, so I'm going to move it to the denominator. So 2 to the negative 2 would be 1 over 2 squared, which I could simplify this to be 1 over 4. Now, number 2, I have 4x to the negative 7. So now I have a base of 4 with no exponent and an x to the negative 7. The negative 7 is only attached to the x, not to the 4. So 4 is going to stay in my numerator, and then x to the 7 would be in my denominator. Because it's in the numerator, the reciprocal of in the numerator would be in the denominator. Number 3, we have 1 over 2x to the negative 3. The x negative 3 is in the denominator, so I'm going to move it to the numerator. Again, the negative 3 is only attached to the x, so I'm going to have x to the third divided by 2. Number 4, we have 3x to the negative 4, y to the negative 9. The x and the y are the only ones with negative exponents, so I'm going to keep the 3 in the numerator and then move the x and the y to the denominator. So x4, y9. Number 5, 1 over 7x negative 4, y negative 1. So it's going to be x4, y1 over 7. Number 6, 7 negative 9 times 7 positive 9. This is a multiplication of exponents. When I multiply exponents, I add their exponents. Negative 9 plus 9 would be 0. So this is 7 to the 0, which is just 1. 7 negative 4 to the 0, anything raised to the 0 power is 1. And then 8 negative 6 to the negative 2 would be 1 over negative 6 squared. And then negative 6 squared would be 36. So this is going to be 1 over 36. Looking at number 9, we have negative parentheses, a bunch of symbols to the 0 power. Now, anything to the 0 power is 1, so this would be negative times 1, which is negative 1. Number 10, 4 times 9.2675 to the 0 power. Again, anything to the 0 power is 1, so this is 4 times 1, which is 4. 11, 10x negative 4, y3, z negative 7. Anything with a negative exponent will change its position from the numerator to the denominator or the denominator to the numerator. So the 10 will stay in my numerator, the y3 will stay in my numerator, and then the x4 and the y7 will change to the denominator. Number 12, negative 18x to the negative 1. X has a negative 1, so it's going to go into the denominator, so negative 18 divided by x. 13, negative 7 divided by 3, I cannot do, so these are going to stay as negative 7 divided by 3. A negative 1 would go to the bottom as just a. D5 would stay. B6 would stay. C negative 3 would go to the denominator. And then E2 would change to the numerator. So E2 in the numerator. And then F negative 9 would also go to the numerator. So we'd have negative 7, B6, E2, F9 divided by 3, ADC to the third. 14, 3 negative squared, X4, Y negative 8 divided by z negative 2. Again, anything with a negative exponent will change positions. So 3 negative 2 would go into the denominator, which would be 3 negative 2, which is 9. X4 would stay in my numerator. Y negative 8 would go to the denominator. And then z negative 2 would change to the numerator. So we have x4 z squared divided by 9y8. 15 x negative 3 y5 divided by 4 squared z negative 4. 4 squared would stay in my denominator. 4 squared is 16. It would be accompanied with x to the third, and then z to the negative 4 would go to the top, and y5 would stay in the top. So z4, y5 divided by 16x cubed, and 16, negative 12, a, b, 7, c, negative 4, d, negative 1. I'd have negative 12, a, b, 7, and then c4, d1 would go to the denominator. In today's lesson, we learned when raising a number to a negative exponent, take the reciprocal of the exponent. So if the number is in the numerator, it goes to the denominator, and if the number is in the denominator, it goes to the numerator. That's a wrap on today's video. We'll see you in the next one.